A very good morning to Dr. Ibrahim and Mr. Afizal. I am from Group 5. My name is Vanessa Jekali and my other two team members, which are Nuraina Shafira and also Annabella Joni. In this open-ended lab session, we are going to do experiment about entropy change. Entropy change is related to the second law of thermodynamics. Energy is the ability to bring about change or to do work. The second law of thermodynamics states that in all energy exchanges, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state. This is commonly known as entropy. The second law of thermodynamics also states that the entropy change of any system and its surroundings considered together, the resulting from any real process, is positive, and the nearly approaches zero is the process which can said to be reversible. Mathematically, the process can be defined as the formula: a total of entropy is more or equal to zero. Other than that, the second law affirms that every process proceeds in such a direction that the total entropy change associated with it is positive, the limiting value of zero being attached only by a reversible process. No process is possible for which the total entropy decreases, which means the entropy cannot be less than zero. Lastly, the practical utility of the second law is illustrated by application to two very common processes. It shows its consistency with our everyday experience, which is the heat flow from hot region to the cold region. The second shows how it establishes limits to the conversion of heat to work by any device. There are two objectives in this experiment. The first one is to observe the entropy change of heated water that has different temperature at a constant time. The second one is to observe the heat transfer from hot region to a cold region.
The hypothesis is the water with the lowest temperature takes the longest time for the temperature to increase. Next, the responding variable is the final temperature of water. The manipulated variable is the initial temperature of the water, and the constant variable is the mass of water and the time to boil the water. In this experiment, we need 300 grams of water at room temperature, cold water, hot water, ice cubes, thermometer, boiler or stove, and stopwatch.
Next, I will explain more about the methodology of this experiment. Methodology of this experiment consists of pre-startup procedure, experiment procedure, and shutdown procedure. The first one is pre-startup procedure. Number 1, make sure the pan is at the room temperature. Next, I will move on to the experiment procedure. Step number 1, pour the water air into a pan and put it on the stove. Record the initial temperature. Step number 2, turn on the stove to the maximum heat and heat it up to 3 minutes. Step number 3, record the final temperature. And the final step is repeat step 1 until step 3 for water B, C, and D. Next, we'll move on to the shutdown procedure, which is make sure we fully turn off the stove. The last slide, I will explain about the safety and precaution. Number 1, lab coats or lab jacket must be worn all the time to avoid any accident to happen. Number 2, turn off the stove knob after the water is boiling. And the last one is be careful not to spill the boiling water to prevent your hands from burning. That's all from our group. Thank you for your attention throughout this presentation. See you next time.